Hi guys, here we are on the UT campus and we're in an occurrence of Cretaceous limestone. We're going to talk a little bit about how these Cretaceous limestones form, because as it turns out, it makes up a big part of what underlies the campus, the city, the region. This whole area from Austin all the way west. Keep driving for several hours. You're on the Edwards Plateau, which was formed in an ancient marine environment when the ocean level was actually up here, and this would have been shallow water, 2 to 10 meters depth perhaps, flourishing with abundant life, much like in tropical environments today that we might see in the Bahamas, the Caribbean, the Great Barrier Reef of Australia. So down here is an outcrop of Cretaceous limestone. See a lot of fractures running through here. The main thing we want to focus on are the rocks themselves. They're limestones, and from our two ways of forming sedimentary rocks, there's way one, the breakdown of pre-existing rocks into smaller particles and their transport and deposition somewhere to make sediments. They get lithified, they turn into a rock. What is that? Yeah, sedimentary rock. Way two is this way. This is a chemical precipitate from an ancient ocean. During the Cretaceous time period, about 100 million years ago, vast shallow ocean, basically the ancestral Gulf of Mexico, covered this area. And as a result of the conditions being perfect for a lot of sea creatures that precipitate a skeleton made out of calcium carbonate, minerals calcite and aragonite, we had billions, if not jillions, jillions is I think 10 to the 18th, jillions of these microscopic sea creatures precipitating their skeletons of calcium carbonate, dying, settling on the seafloor. The fleshy parts of the organisms would be decayed away by bacteria as things got buried, but the solid mineral calcium carbonate minerals of these critters remained behind. They got buried, they got lithified, creating, what is that? Yeah, sedimentary rock is what they made. It's hard to see here, or even if I had a hand lens with me, you'd really need a microscope to see the individual organisms here. They're very small, a lot of them single-celled organisms. But there are some organisms that are not so microscopic, that are also secreting a skeleton made out of calcium carbonate, including this beast right here. This is an ammonite. You can see this coil here from the inside to the outer chambers. This was a chambered swimmer. This is a now extinct cousin of the modern existing nautilus, which you could find swimming around in the oceans if you're lucky. Look at the size of this thing. This thing is really quite striking. So we have both these macroscopic, very large-scale organisms secreting skeletons of calcium carbonate, and we have the microscopic ones. Together, they're comprising the sediments that are chemically precipitating from the oceans. These organisms are using calcium, and they're using dissolved carbonate and bicarbonate to secrete calcium carbonate, the skeleton that supports them, that protects them as a shell, armors them against strong wave and current energy or against predators, those sorts of things. All happening in this shallow water marine environment. So this is way two for making sedimentary rocks. All right, we'll return to this lovely location on the University of Texas campus later in the semester when we talk about human impact on water resources. And we can see some impacts if we pan over here to the right. And we can continue to see the impacts of this water resource running through the campus of the University of Texas. You could also get a feel for that by looking at the creek itself. You'll find not a very diverse set of critters living in this environment. It's not the most encouraging habitat for aquatic organisms to live in due to a variety of impacts that humans have had on this environment. And we'll get to that later in the semester under human impact on freshwater resources. We'll see you then.